Hey there, hopefully you've finished your turn. So the amount of force needed is 0 newtons. Here's the answer for number 2. Yeah, you can take a look at it, see how you did. I wrote constant velocity and changing velocity. There's a few other ways you could describe that reason. And for 3, it's C and A and B. You'll notice in the first part I actually made a note of which way it was accelerating. Whichever way it's accelerating in part A, it's to the right. That's the same way as the net force will be in the part 3. Over here, no yes, yes, constant velocity, changing velocity, changing velocity. Question number 5, here are my answers. 10 newtons left, 0, 15 newtons up. Acceleration, yes, no, yes. Good habit, actually, to include directions whenever you can, because force is a vector, it has direction. All right, so let's take a look at this last part about proportional thinking using Newton's second law. So the first question I ask ourselves is, how is acceleration related to F net? So we did that experiment graphically. Acceleration was dependent, so it goes over on the y. Here's F net over here. So we found that as F net increased, so did acceleration. So we actually had a direct relationship. So in our direct relationship, we could say y is equal to kx plus b, but b is 0 in this case. So y is our acceleration. And we got some slope x times F net. So we could say that, or we could also write it as a proportion, that acceleration is proportional to F net. One thing we did notice, by the way, that this slope here was equal to the reciprocal of mass, which was interesting. So we could put that in words as well. We can say A acceleration is, it's not just linear, because it is a straight line, it's linear, but it's also direct because it goes through the origin. So we can say A is directly related to net force. So whatever F net is multiplied by, so if I'm thinking A is equal to some K times F net, then whatever F net is multiplied by, say times 3, then acceleration is going to get multiplied by the same amount. If the net force is doubled, then the acceleration will be, well, I could just use the same word doubled, or I could say times 2. So if the previous acceleration was 4, the new acceleration would be 4 times 2 equals 8 meters per second squared. Increased by a factor of 2, when you see words like that, this means the same thing as doubled or multiplied by 2. So factor, the word factor actually means something that you're multiplying. So it's kind of weird. You look at the word increase and you think it might mean plus 2, but it actually means increased by a factor of 2 means doubled. Decreased by a factor of 3 means the same thing as divided by 3. So divided by 3. And divided by 3 is the same thing as multiplying. Remember, to change division to multiply, you multiply by the reciprocal, so it's going to be multiplied by 1/3. There are 3 your turn questions, so I want you to hit pause now, give those ones a shot, and then I'll be back in a moment and tell you what the answers were, and you can give yourself nice big check marks. Alright, got some answers for the first 3 questions here. It says the first one is 16, the next one is 2, the last one, it's rank the objects in order of their acceleration. So I wrote on the bottom here, I just did this first thinking about what the F net was in each case. I'm not sure, did you check out this part? It says, hint, are the masses of each object the same? How can you tell? And the answer is, yeah, the masses are the same, because each of those, the force of gravity downwards, they tell you is 50, so therefore the mass must be the same on each one. So that's why you get that CADB as an answer. All right, so we took care of acceleration. We said the acceleration was proportional to F net. And now how is acceleration related to mass? So graphically, when we did this, we found that we had acceleration in F net, and mass, pardon me. we had this kind of relationship. In order to linearize it, we graphed acceleration versus 1 over mass, and then we got a nice relationship. So mathematically, what does that look like? Well, y equals kx. We had, instead of y, we were at acceleration. Acceleration would be equal to some constant multiplied by 1 over m. Or we could say, we could just put that k in the numerator there. We could say k over m. We could also say a is proportional to 1 over m. So I kind of like that. A is proportional to 1 over m. And interestingly enough, that this slope here, that slope was equal to f net. So it's pretty cool at the end of the day here that we can put those together. A is equal to f net over m. We can combine those two together. And it's neat that the constant here, the constant is 1, like we don't have to put any number out front. Another way we can think of this is f net is equal to ma. And if we look at the units here for a second, a mass is measured in kilograms. And acceleration, of course, is meters per second squared. And this f net is measured in newtons, 1 newton. So, of course, they named this after Sir Isaac Newton. So what is a newton? A newton is a kilogram times a meters per second squared. So isn't it nice, actually, that when I say, what's the force acting on this object, and we say 10 newtons, we don't have to say 10 kilograms times meters per second squared. Newton, as a measurement of force, is the exact same as a kilogram times a meters per second squared. So we've just invented that. It's called a derived unit. Okay, so let's continue on here. In words, we could say this relationship, when we see this kind of a graph, or if we see this kind of a shape, that's inversely related. Oh, I got a big font now. So inversely related means whatever one gets multiplied by, say if I say times 2, then the other one is multiplied by the reciprocal. It's kind of like, you see, this is 1 over m. So this multiplication factor, it's 1 over that, right? Of course, you could say 1 over 2, or you could also say divide by 2. You can go either way on that. An object is accelerating at a rate of 8 meters per second squared. When it suddenly has its mass increased by a factor of 2, which means we're multiplying the mass times 2, the new acceleration will be, well, we're going to say 8 times 1 over 2, which is going to be equal to 4 meters per second squared. Here's the question, says an object is accelerating at 8, again, when it has its mass decreased by a factor of 4. So I'm going to put this in terms of multiplication. To decrease by a factor of 4 means to multiply by a quarter. Yes, sorry about that. Yes, you can also have a divided by 4, but it does work out nicely just to keep everything in terms of multiplication. So I'm going to say decrease by a factor of 4 means times a quarter. So because the relationship is inversely related, so again, I'll just go back over here and say, okay, so if I had this one was times a quarter, then the acceleration gets multiplied by the reciprocal of a quarter, which means times by 4. So I'm going to say that this one is 8 times 4, which would be 32. All right, are you ready for a crazy one here? So again, I'm going to say A is equal to F net over M. And let's see what's happening here. In fact, maybe I'll pick a nicer color for us. A is equal to F net over M. Now in this question, what's going on? The net force is increased by a factor of 3. So that's this part here. The net force is increased by a factor of 3. So in other words, I'm going to multiply this times 3. What effect will that have on the acceleration? Well, since the F net is in the numerator, since it's directly related, then acceleration is also going to get multiplied by 3. Now the other piece here, it says, and mass is decreased by a factor of 4. Well, if it's decreased by a factor of 4, that means mass is multiplied by 1/4. And now the acceleration is going to get multiplied by the reciprocal of a quarter because this mass is in the denominator, or it's inversely related. So I'm going to say here times the reciprocal of a quarter is 4. So what's going to happen here, I'm going to get 8 times 3 times 4, which is the same thing as 8 times 12. 80 plus 16, 96. 96 meters per second squared. There you go. I got one more example here. It says if the downward force is gravity, so this one here is gravity, I'll just put it in there, Fg is equal to 40 newtons. Find the acceleration of the object. Okay, so the acceleration, what's a nice color here? Back to green. Acceleration is going to be F net divided by its mass. So looking at it, it looks to me like the F net is 20 newtons left. All divided by, well, what is its mass? I guess we have to figure out its mass. Well, if the force of gravity is equal to 40 newtons, force of gravity is equal to 10 newtons per kilogram times the mass. So if this is 40 newtons, here I'll just go without the units here, 40 is equal to 10 times the mass. So in other words, the mass is going to be equal to 4 kilograms. So that's what we figure out from this. So, quickly in your head, you look at 40 and you say, if I divide by 10, I get the mass. So here I put a 4, and 20 divided by 4 is 5. The units for acceleration are meters per second squared, and I do know the direction. It is left. And so that would be my answer. Cool. All right, we are done now for your own work. We have balanced forces versus unbalanced forces. We've watched the video, so you can check that off now. Second part is now you need to complete these 3 MOPs. Just a reminder, when you do those MOPs, you're going to have to use Internet Explorer or it won't work. If you go to physicsclassroom.com, I'll write that in here, physicsclassroom.com. The first thing you're going to look for is Mind on Physics Legacy. Once you clicked on that, on the next page, look for something that says Start Mopping. Once you got that, you got a couple choices. What do you want to do? Do you want to do for credit or for practice? You want to do it for credit mode. The teacher code you want to put in is NMCS. The student ID is, your 4-digit ID. And whatever you're going to put on the form for me. And when you're done with that, when you get a code, the code's going to pop out, and you can pop it in here on the reverse side of the sheet that you were checking off. And L2 would be the name of the MOP. And then I think the first letter either starts with a G or an S. A G or an S. A G if it's gold, an S if it's silver. So what I'm going to do is I'm going to say if it's gold, you can get a 5 out of 5. If it's a silver, you get 4 out of 5. So that, just to indicate that you had a little bit of trouble with it, but you got through it finally. So, and again, if you have any problems with those or if you had any questions, please ask me in class. Thank you very much, and I will see you soon.